for site verification, we commonly use the sand replacement test, or sometimes it's called field density test. And then it is based on usually based on British Standard 1377 or MS 1056, and the compaction requirement is usually for land development project is 90%. Sand replacement test is done according to the standard I mentioned just now in our lab, HBPTU testing unit, which is an accredited lab I mentioned before, accredited by the Standard Malaysia and also ILAC MRA, the international partner of Standard Malaysia. Our lab will carry this test that is called determination of dry density or field density of soil sand replacement method. We carried out according to either BS 1377 part 9 clause 2.1 and 2.2 or MS 1056 part 9 2006 clause 4.2 and 4.3. It depends on the client. Sometimes or specification of the authority. They will sometimes specify certain standard for the lab to test it according to certain standard. But these are the two common standard that we use for the test. Of course, just now we look the proctor compaction in the lab also is based on another clause 3.5 and 3.6, and for British Standard 1377, and for Malaysian Standard 1056 it is clause 4.2, 4.5 and 4.6, using 4.5 kilogram rammer, which is the heavier rammer. The other one is 2.5, remember, but these days we have a very heavy compaction roller and machinery, so normally this is preferred test for proctor compaction test. So this test or the benchmark test is done in the lab, and then we the HPPTU lab is capable of doing this. You can come and visit the lab and see the operation. And same thing, if we need to go to the site to verify the site, we will also be able to go to the site and carry out the field density test using sand replacement method. Okay, let us go back to the example just now. Okay, this is usually what you will see the tester. For your information, in the accredited lab operation, there are several definition and terms and qualification used for people who are involved in the testing. One is a tester. Second is a signatory. The tester is the person who will do the test, and the signatory is a person who know about these tests well, that has been verified their competency to endorse tests. So the tester will usually collect this kind of information. The initial mass of sand, what is the amount of sand? The remaining sand after you put inside the hole, and then the mass of soil that you excavate from site. After that, he will need to identify what is the moisture content of the soil, and then he need to establish the density of sand. But remember, the density of sand is known because it is standard sand that is used by the lab, right? Which is the sand that pass 600 micrometer sieve and then retain in the 300 sieve. The volume of cone. This is actually the volume of cone is for the for the container. Remember the container with the cone that we used to release sand? So we need to know the volume of cone so that we know what is the amount of sand that is actually in the cone but not in the hole. So we need to deduct that, remember? And from there, we are able to calculate the gamma density, the dry density, and also the compaction. And then finally, check what is the compaction ratio. Compaction ratio means the result from the field density test compared to the result from the lab test. So that's what we are looking for, to verify whether the work on site is acceptable or not. Okay, let us look at a slightly more detailed calculation. So from here, we look at this calculation. Mass of sand, that means the cone and the hole is this much. We know, and then we know the wet soil, because remember when you excavate, you put in a plastic container and then you weigh them, then you get the mass of wet soil. The volume of cone plus hole, and then we need to find the volume of hole only. Then that means we need to deduct the volume of the cone, or the weight of the sand in the cone. Then we can find out what is the volume of the hole, which is uneven. That's why we need to use the sand. And then the wet soil is, remember, the wet soil, you just weigh them to get the volume. The density of the wet soil, then you divide the weight of the wet soil with the volume of the hole. Then you get the density of the wet soil. Then how to get the dry density? This is the formula, which is gamma dry equals to the wet density divided by 1 plus the moisture content of the soil that you excavate from the hole. Now you will get your compaction dry density on site is 17.36. Now this one need to be benchmarked against the Proctor result in the lab. Now the Proctor result, just now remember, it was 19. The peak of the chart just now, it was 19. So this is 19, and then this is the result from field density test. If we calculate the relative compaction, it is 91.36. Remember the spec was 90%, so that means this compaction is on site is acceptable. Next question is, what if this percentage is less than 90%? And which is supposed to be rejected, right? There's no choice. You need to keep compacting until it reaches 90%. But sometimes there are reasons why the compaction did not reach 90%. First, it could be because of not enough moisture. Second, too much moisture. In the case of too much moisture, for example, you are doing your earthwork operation. Suddenly it rains. That means you cannot be doing the roller compaction during rain. You stop and then you will start again. But definitely you cannot start immediately. You need to leave it to let the water go, and even then, you will still need to do what we call reaping. You will see in the construction specification, if that says that if the soil has been exposed to rainfall, for example, you need to allow it to dry for 1 day, and the next day you come and back and then you do ripping and remix the soil on the surface and recompact. So that one you need to carefully read the what they call is construction specification, and that is required by the document, the contract document. But in the case of there's no rain or nothing, but it still doesn't achieve 90%, it could be because lack of moisture. So you need to, again, same thing, you need to do ripping and then spray some water and then recompact. And that way, the required compaction can be achieved. So those are the things that need to be done in case your compaction does not reach the required specification. Another terms that is that you will probably hear on site is relative density. Relative density is actually another indicator of the need, and then this relative density is more specific to cohesionless soil or sand. Okay, because sometimes you go to a sandy area, you don't know whether the sand is what I call loose or dense or very dense. If it is in dense and very dense condition, that means whatever the what I call the strength that he's got should be sufficient to support loading, the bearing capacity of the sand. But we don't know. So what we need is an information on what we call information on relative density. So what does this relative density do? It's actually the in-place density. I mean the situation on site, the in-place density compared to its lab maximum and minimum density. The sample will be taken to the lab, and then you will find what is the maximum density in the lab, and also what is the loose density in the lab. So this relative density is a density compared to lab maximum and minimum density. Then we can calculate what would be the relative density. And this relative density will tell us the condition of the soil on site, whether they are loose. We can consider them loose sand or medium dense sands like this. They are loose or mid dense or very dense or very dense. It depends on this relative density that we have calculated using the formula that I showed you just now. So if the range, let's say, if the density is less than 35, the sand on that side can be considered loose. When it is loose, it has very weak bearing capacity. That is the conclusion that we can make. But if it's dense, the relative density should be between 65 to 85. And it can be considered very dense if it's more than 85, and the unit weight is more than 20, and the bearing capacity should be very strong to support load. So that is another indicator of the condition of soil on site if you need to do the assessment of existing soil.